Hi there, welcome to another video from Hegarty Maths. It's Mr. Hegarty here, and we're completing a Decision Maths A-level video on critical path analysis. It's the second video in this series. What I'd like us to do in this video is I'd like us to be able to represent a project using an activity network. And for simplicity, we're not going to use dummies in the first case. Now, you don't know what dummies are yet because we've only done one video on this topic. We will learn about that in the third video. But we're just doing a more simple case here, just so you understand what an activity network actually is. Okay, so let's just review where we got to in the first video. Don't have to write this down, but that's a paragraph we talked about in the first video, the making of a textbook, and it had various activities A to G. Now, what we did in the first video is convert a paragraph of text into what's called a precedence table. And the precedence table was a way of summarising that paragraph in a nice simple way to show us what activities we have. We have the following 1, 2, 3, 4, 5, 6, 7 activities and what each one depends on. Okay, so imagine we got ourselves to that point there. Now, the problem with this is it's not very visual and it doesn't always show the intricacies of what must happen before what. So it's not sort of like you can't look along it and see the time frame. So we want to convert this to a picture, and the picture we're going to use is what's called an activity network. Okay, and there are some rules that I'm going to just set out at the top to help us draw this. The first rule is this, that I'm going to use an arc or an edge to represent an activity. Okay, that's how I'm going to do this. An arc or an edge is going to represent an activity. A node, okay, is going to represent what we call an event. And that's the completion of an activity, or more than one activity. Okay, so an event is where something's finished, and that's going to be shown by a node. There are some, a nice little tip here for you, in particular for events. Sometimes it's hard to know when events occur when you're drawing these out. And events occur in two ways. So events occur, firstly, when there is a dependence. For example, here, when there is a dependence. And what I mean by that is, because C depends on A must be finished. So in order to have C starting off as an activity, you must have a node there to say that A is finished. So when there's a dependence, which is immediate. And the second way an event occurs is if there's been no immediate dependence on that activity finishing, but the project must finish. Now, probably this sentence doesn't make sense until I start off with my picture in this example. So just bear that in mind for now. Write that down for now, and I'll come back to it at the end to show you why it's useful to think in those two ways. And the last thing I want to say is that is a little tip for you. Each arc must be a straight line, and what this means is you may have to redraw picture more than once. Okay, you may have to redraw the picture more than once to achieve that. So be aware that when you're doing these questions, you may have to draw out the activity network a couple of times to get it looking the right way. What I'm going to do now is I'm going to show you how to draw an activity network for this precedence table. I'm going to go onto a new slide where the same table's on there and this writing isn't. But I'm going to come back to this slide and refer to it to show you what I meant when I was giving you this introduction. Okay, so here we go. Let's move on to another slide. Here's the exact same table. And what we're going to do is we always start off these diagrams with a node, an event as such, and the event, we're going to call it the 0 event. It's just the start of everything, so nothing's happened beforehand, and we call it the source node. Okay, like that. Okay, so looking at a table, activities A and B depend on nothing having happened before. So A and B are certainly the first ones that kick off in this project. So I'm going to draw with an arc A, and I'm going to draw with another arc B, coming out of 0. So we've completed these two. Now, activity C depends on activity A having been completed. So A must finish. So looking back at our picture here, do you remember when I said here that an event occurs when there is a dependence, immediate dependence? This here is an immediate dependence here. C immediately depends on A, so I'm going to finish off A with an event, which I'm going to call 1, and I'm going to have C coming out from it, like that. And I'm going to tick that off. D also depends on A having happened. So I've already finished A off, that's fine, but D depends on A, so I can have D coming out of that event there, as follows. Right? And we're completed to there. Now E depends on B having happened. So I'm going back here to our picture. An event occurs when there's an immediate dependence. E immediately depends on B having been finished. So I'm going to create an event, which I'm going to call number 2, and I'm going to have E coming out from it as follows. Right? And I'm done up to here. Now activity F depends on C and E having been completed. So C and E have to be completed. Now C and E are apart from each other, and it would be much better if they were right beside each other, so you could have them both coming in to the same event, i.e. when they're both complete. So I'm going to start off redrawing this picture underneath here. It would have been better if C was down here. So what I'm going to have is I'm still going to have A coming out, absolutely no problem. Still going to have B coming out like that. Still going to have activity 1 and activity 2 as follows. But this time, instead of C going up the top, I'm going to have D going up the top like that. And I'm going to have C coming down. It doesn't make a difference which are on top and bottom. But I'm going to have E coming up like that. Okay? And you know that F depends on C and E, so I can create an event where C and E are complete, which I'm going to call event 3. C and E are complete, and F comes out. F happens after that, so F comes out here like that. And we're completed up to there. Now lastly, G depends on D and F having been complete. So D and F have to both finish at the same, so D and F, so I can draw an arc here now, and I know it's not straight currently, but I'll fix that in the last round, and I can call that an event, event 4, D and F must both finish, and G happens after that. Now that's not the end of the picture here, although I've done up to there. Look back on my slide here. An event also occurs when there's no immediate dependence, but the project must finish. Obviously this whole project must finish, so everything else depended on something apart from G. So we must finish this off with an event 5, which is basically the project completing. And just like we called the initial the source node, we have a name for the last node, which is called the sync node, which means everything that didn't have an immediate dependence, everything which wasn't required as an immediate dependence goes into that. Okay, so there's our picture. Now the only thing currently wrong with this picture is that it's got sort of not straight lines. So what I'm going to do is I'm going to start off the process. I'm just going to I'm going to draw it with a straight line, okay, at the end when I know I can do this. So let's just do it really neatly. That's 0. I'm going to have a straight line coming out here, like these two. I'm going to have 2 events here, like that. I'm going to have this one coming down here, this one coming up here, to another event being completed, should be here. And then what I'm going to do is I'm going to have this going into another event, maybe like that. This coming down here to this one here. And lastly, I'm going to have the last one coming out like that, and the final one. So it's important at the very end to draw your activity network neatly with straight lines. So this was a 0, 1, 2, 3, 4, and 5. All I'm doing is stopping that being a sort of a not straight line. This was activity A, this was activity B, this was activity E, this was activity C, this was activity D, this was F, and lastly this was G. And there we go, that's our perfect activity network for this precedence table. Just to think now, why is that better than the table? It's really helpful to see what must have happened first, what must be completed. Every time you see a number, that's telling you what has to be completed up to that stage. For example, at number 3, C, E, B and A must all be completed, but D not yet, F not yet, and G not yet. And it clearly shows you almost like a timeline here from the start to the end, the order in which things can occur. Now, you have enough knowledge now to be able to do the next 2 examples on your own. The activity networks can get complicated. Just bear in mind, like I did up here, I started off doing one, I changed it, and then I had lines that weren't straight, so I drew it out one last time. It may require you to do that. So what I'm going to do is I'm going to give you 2 more questions to try. I suggest you try these on your own before you watch me, and I'll go through them in 10 seconds. So here's the first one. Have a go at that one, drawing the activity network corresponding to this precedence table. I'll go through in 10 seconds, so pause the video. Okay, so to start with, we're always going to draw our source node here, so that's going to be 0. Okay, and activity A and B depend on nothing. So I'm going to have A and B coming out here, like this. Okay, in fact I might even draw that bit up here because I might have to redraw this a few times. So I've done up to there. Now activity C and D depend on A having happened. So because there's an immediate dependence, A must be completed, and I give it the number 1, and I'm going to have C and D come out like this. C up here, D down here. So I'm done up to here. Now E and F depend on B having been completed, so there's an immediate dependence here. So let's have the event that B is complete, and let's have E and F coming out. Maybe E up here, and maybe F down here, like that. Activity G depends on activity D having been completed, and activity H depends on D having been completed. So there's an immediate dependence here. G and H depend on D. So I'm going to close off D. I'm going to give it the number 3. And I'm going to have G and H coming out like this. G there and H there. Now, I depends on C and D having happened. C and D are very far apart from each other. It would have been way better if they were beside each other because they both have to end for I to happen. So at this stage, I'm just going to take a second to redraw my picture. So let's write 0 here. Let's have that A and B, just like we had it. Let's have that 1 and 2, as we had it. Now instead of C going up and D coming down, I'm going to have D going up and C coming down, like that. And E and F are fine as they were, so I'm going to have E coming up like that, and I'm going to have F coming down like that. Now let's finish off where we got to with D. D had already finished, and that was number 3, and I had G and H coming out of it. So I'd have G and H coming out of it like that. Now the beauty of doing it like this is I depends on C and E. C and E are here, so I can close that off with an event 4, and I can have I coming out like that. Now J depends on F having happened, so I can close off F, which is going to be number 5, and I can have J coming out, so J's coming out. Maybe I'll do it up like that because they might all meet. Now it looks like it's going to get potentially confusing here. K depends on G, I and J having happened, so G I, and J having happened. So it would have been better if they're close together. Now what I could do here, if I'm clever, I could just swap the G and the H so that the G's coming down to meet the I and the J. So I'm just going to do that rather than redraw the picture. So I'm going to have H up here and G here. So this is coming down, this is coming down, and this is coming up. G, I, and J all need to finish. So I'm going to draw a diagram like that, and they're all going to finish, and I'm going to call it number 6. As follows, and I've done all that. And L depends on H and K finishing. So L only finishes when H and K finish. Now, K coming out here like that. And L depends on both these finishes. So I'm going to make that sweep down here, and I'm going to create another event, which is 7. And I'm going to say that L depends on that. Those two. But lastly, I've got to finish this all off. The only one that hasn't had a dependence before is L, so that's going to be number 8. Now, that picture is a messy picture. It's got lines that are bending, etc. So I'm just going to take a second at the end to draw it properly. So I'm going to draw it properly with straight edges. So here we go. So I'm going to have one there, 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 maybe there like that. So hopefully this will work out for us. So I'm going to have I'm missing one here. That coming down here, that coming down to there, this coming across here, this coming up to here, this coming across here, and this coming up here. So that's a much neater answer. So this is going to be, I had them as before, 0, 1, 2, 3, 4, 5, 6, 7, 8, and make sure you label each arc as an event. So this was event A, as an activity A, B, this was F, this was E, this was C, this was D, this was H, this was G, this was I, this was J, that was K, and that was L. And we're done there. We've got a nice, neat activity network to represent that precedence table as follows. One, I'm going to actually give you the precedence table. I'm going to give you the activity network and ask you to draw the precedence table. So you should be able to do that. Pause the video. I'll go through in 10 seconds. So what we've got here, there should have been a line actually here. It's not as clear as it should have been. So what we're going to draw is we're going to draw our table. So our table is going to have our activity and depends on. And we've got activities A, B, C, D, E, F, G, H, I, J, K, and L. So we've got quite a lot here, so I'm going to have to extend the page here. So it goes all the way up to L. So we've got activity, we've got, what do we say? A, B, C, D, E, F, G, H, I, J, K, L, J, K, and L. Okay, now A happened from the start, so A didn't depend on anything, so we put nothing there. We've dealt with that. B depends on A having happened, so B depends on A. C depends on A having happened, so we put C depends on A. Let's go to D. D depends immediately on B having happened only. It obviously depends on A implicitly, but immediately depends on B. So D depends on B, done. E depends on C having happened. Okay, so E depends on C having happened, done. F depends on E having happened. So F depends on E having happened, just looking at this here. F depends on event 4, which is E having happened. Now G depends on C having happened, so G depends on C having happened. So we've done there. H depends on 2 things, D and F having happened. So H depends on D and F having happened, so D, F we put here. I depends on G having happened, and J depends on G having happened. So I and J depend on G having happened, both of them. And we've done this here. K depends on I, so K depends on I here. And L depends on J having happened. So L depends on J having happened. So that's it for this video. That's everything you need to know on drawing an activity network without dummies. The next video will do the same thing, but we'll talk about dummies.